this is our position function here. It says again, a particle moves along according to the law of motion. S is equal to F of t. T is greater than or equal to 0, where t is measured in seconds and s is in feet. This function right here, as you already stated, you can't write it as a polynomial. So when we take the derivative, we will have to use the quotient rule. Before I do that, I would like to get an idea of the graph of the function so I can start to predict the behavior of the derivative as well. So I'm going to go into my calculator, and you should have your calculator. We're going to use it a lot today. If I go into y equals parentheses 4t minus 10, and on the AP exam, they will actually give you problems that basically require the use of a graphing calculator. So I gave you one yesterday, works out nice as a polynomial. This is one you would want to use your calculator on. And I'm going to graph that, and it's an interesting looking function. We haven't seen a lot of functions look like that before, but this one's kind of neat. And here's what it does. So it kind of bottoms out right around here, um, crosses through right around there. Just something like this. Okay. So you tell me, derivative can be positive or negative right there, or 0. Right where the red dot is. Negative. Oh, here. Here. Are we concerned about negative time? No, we're not, because our domain says that TSB greater than or equal to 0. How about right here, derivative positive or negative, or 0? Positive. Still positive. 0. And it will move towards 0, correct? So we can kind of see that, the derivative right after 0 is the derivative positive, negative, or 0. Positive. So this object is going to start by moving in the direction to the right or in the direction to the left. Which one? Direction to the right, because it's moving in the positive direction. The derivative is positive, so it's moving in the forward direction. Okay, so good. I want to find the derivative, and in order to do that, we need to use a quotient rule. It says find velocity at time t. On your AP exam, you'll actually write this: s prime of t, showing that you're taking the derivative of the position function, is equal to v of t, which is equal to, I've used the quotient rule. So I take the derivative of the top. What's the derivative of the top? 4 times the bottom left alone, t squared minus or plus 3, minus the top left alone, t squared, I'm sorry, up the top left alone, equal 4t minus 10, times the derivative of the bottom. What's the derivative of the bottom? Hold on. Cold. Just 2t. So I'm going to put that on the end right over here. And that's all divided by t squared plus 3 quantity squared. I square the bottom. Now what I'm going to do is I'm going to simplify this. So let's try to look through what squared terms am I going to have. I got 4 squared, and what else? Negative 8 squared, so that'll give me a negative 4 squared, 4t squared. Now I want my linear terms, so to the first degree. What am I going to have? That's to the first degree. You see that? It looks like a negative and a negative is going to make positive, so I'm going to have positive 20t. And then how about constant terms, things that don't have any variable attached to it? 12. And that's going to be all over the quantity t squared plus 3 quantity squared. So that's my derivative. Doesn't look pretty, doesn't have to. We're just going to use it in order to answer the questions that we have in front of us. So something you need to state before we actually do this part, which is B, is we have to be able to identify something interesting about this derivative. Look at the bottom. What do you notice about the bottom of this derivative? Think in terms of positive, negative, and 0. What do you notice about the bottom of this derivative, the denominator? Why is it always positive, Kyle? It's squared. If you square something, it's going to be positive. So it's like positive triple, right? Because t squared is positive, right? If you add 3, it's still going to be positive. And if you square it again, it's still going to be positive. The bottom is always positive. Okay? So that's something interesting to keep in mind. All right? Let's go to the next question, then we'll graph this. It says, what is the velocity after 3 seconds? How do I figure out what the velocity is after 3 seconds? What do I do? Yeah, to this right here, right? I'm actually going to put that in right here so I can sketch a graph as well. So negative 4t squared plus 20t plus 12 divided by t squared plus 3 squared. And if I go to my table is generating all values now. So I'm going to go to my table set and I'm going to go down to ask. And at what time do I want to know the velocity? 3. So I go to my table and I plug in 3. And am I looking at y sub 1 or y sub 2? 2, because I put the derivative in for y sub 2. This is going to tell me my position. This is going to tell me my rate of change or my velocity. So therefore, I have the velocity at 3 seconds is equal to 1/4. Because it's a derivative, I need a label. What's my label? Feet per second. All right. When is the particle at rest? What do we use to determine when the particle's at rest? Yeah, when it goes from negative to positive and when the, what'd you say? When the slope is 0. When the derivative is equal to 0, that's when the particle is at rest. So I'm going to look at my derivative. I have to find out when that thing's equal to 0. Is the bottom ever equal to 0? Why? The bottom is always positive. So true or false? This function right here will be equal to 0 when the numerator is equal to 0. Yes, because 0 divided by a positive is 0. So we don't need to worry about the denominator. Let's worry about the numerator. I want to solve that equal to 0. How do you find where negative 4t squared plus 20t plus 12 is equal to 0? What would you use? Quadratic formula. Type it in your quadratic formula calculator. What do you got? Give me a value. We got A is negative 4, B is 20, and C is 12. People should have that typed in, I'm guessing. What do we get? Okay, so are we concerned with negative time here in this problem? No. So at time is equal to 5.54 seconds is where the derivative is equal to 0. The particle is at rest, and it's going to change direction. Yes. It changes direction twice. So it would go like this. Yeah, it would go forward, then it would back up, and it would go forward again. Yeah, you could totally have that. And you do in your assignment, okay? All right, let's graph this derivative. Sketch my graph. And it's hard to see with the other one on there, so I'm going to graph it again, but I'm going to take the first function off by pressing enter. I go back to graph, and I get that shape. Now, we said that it's equal to 0 at 5.54. So what does that mean graphically for the derivative? If it's equal to 0 at 5.54, what does that mean for the graph of the velocity function? What is the graph going to do at 5.54? The slope isn't going to be 0, but it's going to cross the x-axis at 5.54. And so it's hard to see by this picture right here, but that's what's going to happen. So I'm going to try to draw this picture as best as I can. It's not a difficult, or it's not an easy graph to draw, but okay, here's a challenging question. right after 0 is the particle moving in the positive direction or the negative direction? You're moving in the positive direction when the derivative is greater than or equal to 0. Is this greater than or equal to 0? Why? Because it's above the x-axis. So therefore, we know it's moving in the positive direction right away. So it says, when is the particle moving in the positive direction? Wherever the derivative is above the x-axis. It's above the x-axis between, don't do that. It does it every time during this hour, doesn't it? It doesn't do it any other time. I wonder if that happens on YouTube. I haven't watched. 0 to what? Where is it? 5.54. That's where it's moving in the positive direction. That's where it's above the x-axis. Second part says find the total distance traveled during the first 8 seconds. Yeah. Well, technically at 0, it has an instantaneous velocity. I won't be critical on that, but technically at 0, it would be headed in the positive direction from the outset. Okay? Because at 0, it's sitting above the x-axis. At 0, it's sitting above. We would say that that's included. But at 5.54, it's sitting on the x-axis. Does that help? Okay, find the total distance traveled. I have to check 3 spots when I find total distance traveled for this one. What do I check first? The beginning, which is going to be s of what? 0. Then I have to check the change, which is s of 5.54. And then I have to check the end, which is... Now, a lot of times, again, people want to check the beginning and people want to check the end. But if I just check the beginning and the end for myself, what would be my total distance traveled? 0, right? But that's my displacement. In order to check to see my total distance traveled, I have to also check where I am when I change directions. So let's draw this graph and let's get it figured out. S of 0. Which one of my functions represents S? The top one or the bottom one? Top one. So I'm going to turn that one back on, go to my table. I type in 0. What is my position at time 0? Negative 3.333. That's my position. I'm traveling at a rate of 1.333 meters per second at time 0. But we're wondering about position. So at time equals 0, I'm at a position of, we'll put 0 here. I'm at a position of negative 3.333. And that's at time is equal to 0. Sorry, I put those together. I wasn't thinking. What's the next spot I want to check on my calculator? Yep, change, which is 5.54. And I get 0.361. .361 at time is equal to 5.54. What's the last spot I got to check? 8, which is the end. And that's 0.328. That's at time equals 8. So the motion of this particle, it starts here. After negative 3.333, where does it go to? 0.361. And after 0.361, back to here. So I want to calculate the total distance traveled. How far does it travel to go from negative 3.333 to 0? 3.333. Plus, how far does it travel to go from 0 to 0.361? 0.361. Plus, how far does it travel to go from 0.361 to 0.328? Whatever 0.361 minus 0.328 is, correct? whatever that difference is. We'll calculate that when we get back. Go have lunch, fill your brain with some food, and we'll get back to it. After this, we're done for the day, folks. You'll have time. Okay, so let's finish this off. Uh, we said that we were traveling 3.33 units from the negative to 0, and then 0.361 from 0 to that spot, and then we had to figure out that difference. And so we will do that. I will turn my calculator on. It won't turn on because it's dumb, and I'll reset it and waste more time. So we have 3.333 plus 0.361. You may be asked why I'm going to the thousands. That's because the AP exam will actually ask us to write to the thousand. Minus 0.328. Parentheses. Enter 3.727. That's it. Your assignment, pick up from yesterday.